Welcome back to the course Modeling Combustion with ANSYS Fluent offered by Adult Systems. So in today's class, we will start with Introduction to ANSYS Fluent. So what is ANSYS Fluent? ANSYS Fluent is industry-leading fluid simulation software which is used to solve any physical problem present in our environment using computational fluid dynamics. ANSYS is a big company which has various softwares to deal with meshing, to deal with post-processing, pre-processing, solving, simulation, etc. So Fluent is one of the CFD solvers offered by ANSYS which can solve all these kind of advanced problems, that is streamlined workflows, electric motor cooling, multi-phase flows, battery modeling, turbulence modeling, and the problem with which we're going to deal, that is the combustion modeling. So Fluent provides a platform to solve all such kind of problems numerically using CFD. So conservative equations, mass, momentum, energy are solved for each kind of problem and various results can be generated and validated. So what all are complexities involved while we deal with a combustion problem? So as it is a combustion problem, there will be fluid oxidizer. So chemical species are there. So chemical kinetics will be a part of a combustion problem. Heat is generated at the same time, reactants are getting consumed and new products are formed. Turbulence is generated when the flame is propagating in the domain. Turbulence is interacting with chemistry and vice versa. Phases are getting changed from liquid to gas or maybe gas to liquid. So these all things are involved when we are dealing with a combustion problem. So how ANSYS Fluent can be the code of choice to model such kind of combustion problem. So Fluent has outstanding set of physical models, and the key for such models is that along with the primary conservative equations, that is mass, momentum and energy, Fluent solves an additional equation, that is species conservation equation. This species conservation equation is a special equation because it involves all the complexities which we have seen in the previous slide. Those all complexities are just handled with this one single equation, species equation, and with this Fluent has an extraordinary set of models which can be used to solve evaporation problems, droplets, pollutants, radiative heat transfer, and so on. So these Fluent also has a separate primary combustion models to solve combustion problems. So premixed, non-premixed and partially premixed are the basic and the primary combustion models used for combustion problem in ANSYS Fluent. Along with this, species transport is one more model which can be used to model a combustion problem. So we're going to see how each of these models are used to solve a combustion problem. So now we will see a demonstration of introduction to ANSYS Fluent. So basically, after importing a mesh, what all things we have to carry out when we are setting a problem and all the related things we will discuss in this demonstration. So let's begin. So this is how ANSYS Fluent's GUI looks like. So I'm using ANSYS 2020 R1 version here, and I've adjusted the colors according to my convenience. Otherwise, it looks bit different. It looks bit brighter. So here in the outline view to the left, we can see there are three things, that is setup, solution, results, and at last this parameters and customization. So basically in CFD, there are three things, that is pre-processing, solving, and post-processing. So pre-processing refers to the setup of everything, enabling the models, giving boundary conditions, then initializing the solution, then starting the solution. So these all steps are till pre-processing. Then it comes solving, that is the simulation which it goes, that is called solving. Then it comes to post-processing, that is visualizing the results according to the need. So these all things are clearly seen here, that is setup and solution. So these all things include solving and pre-processing, and the results, parameters and customization are for post-processing purpose. So these all things can also be accessed for the horizontal upper tab, which we can see, that is after file we have domain, then physics, user defined, solution, results, view, parallel, etc. So we can access from the outline view also, or from the upper horizontal tab also. So I'll just adjust this so I get full screen visible. Then here we have this task page where whatever things you select in outline view, those all things will be displayed in the task page. This is the display view. Here you will see the mesh and everything, whatever things are going in. In simulation we can see monitors, we can see residuals and everything. Then here we have several things like zoom to area, zoom in, zoom out, fit to window, titles, visibility, etc. So like this we can use this various display options. Then here we have this console. So in console, whatever things we perform, whatever information we are giving through a click, we can see reflected it back in console. So when we are starting Fluent, first the license file and everything information regarding those things are given. Then after importing the mesh, we can see the various details of the mesh. So what all parts are there for the mesh and everything we can see here. One can also give an input in Fluent through selection by click, whatever click we are doing. That way also we can perform, or we can also do it with this text interface using console. So we will discuss some of these things in detail in this class. So in general, here we can see there are various options for mesh and there are various options for solver. So sometimes we need the scale option, that we have modeled our geometry in some other units, and when we are importing in Fluent it comes into other units. So we can change and we can scale our geometry. Next is for check. So once we have imported a mesh, it is always necessary to check our mesh for if there are any errors. So here in console it will show. So it has shown no errors. So our mesh is good. We can go. Then it is report quality. So this will show how much quality it is there. So it is a very good practice to check our mesh and report our quality before we begin our simulation. That's why it has kept at the very first step in ANSYS Fluent. Then in display we can go and we can change our view however we want. So now here we can see that this is an interior view. So I can just go to this outline and I can select what all things we need. And then we can see display. So it may happen sometimes that you forget that which face is your inlet, which face is your outlet. So this option can even help you in identifying those. So I'll just switch off this outlet and I'll put display. So now inlet is highlighted here. So even inlet is highlighted here. So the yellow part here is the inlet and the other one, that is the outlet. So this way we can use our display options. Similarly, you can change the colors and everything. Everything you can customize according to yourself in ANSYS Fluent. Next, units, you can change the units for each and every, like whatever default units are present here. So you can change those units according to your problem. Next, in solver, you can select the type, it is pressure based or density based, what type of solver you are dealing with. Then velocity formulation, that is either absolute or relative. Then in time, you can do a steady state simulation or a transient simulation, that is time dependent simulation. So then we can select 2D space, that is planar, axisymmetric, swirl. Also we can include gravity effects, so you just have to provide gravitational acceleration values according to your problem. So this is a very specific and particular kind of setup. So from here, what all things you changed based on these parameters, everything will be changed in the next parameters. So based on your problem, what kind of problem you are dealing with, either it is a heat exchanger, a combustion, or solidification and melting, a caustic structure, anything, whatever the problem is, first you have to identify the model which you want to use and then you can proceed forward. So you can select the energy equation. Then for viscous, various turbulence models are present here. Then combustion modeling, which we're gonna discuss, it includes through the species tab. So I'll just open this and I'll show the species models, what are models we'll see. So this one is species transport. First we will look into species transport model. So we will discover all these options. Then we will go to this non-premixed combustion model. Here there are several tabs. So we will discuss these tabs as well. Then when it comes to pre-mixed combustion model, so what all other options are present. So we'll explore everything. Then partially pre-mixed combustion model. So how these things works and everything we will discuss in the further classes. Then after giving models, it comes to materials. So after defining a model, we have to define our materials. What will be the fluid and what will be the solid. In fluid, if it is air, we can go and we can change the parameters, we can change the properties, everything we can change according to our problem how we want it. Also we can do it for the solid. We can also add new material from Fluent database. There's a vast database out of which we can add anything. If you want to add this, we can change certain properties of this material and then we can proceed further. So I'll just close this. Next it is cell zone condition. So particularly, I'll just make it the zone type so we can identify. So here particular cell zones, that is for fluid and solid, what all cell zone conditions we can give. So this is a fluid, so I'll just go into edit and we can see what all conditions we can change. So we can give a frame motion, a porous zone, laminar zone, source term. We can put a source term so that a heat, like a heat source, we can provide. So these are things we can do into cell zone conditions. Then it comes the main, that is the boundary conditions. So here in inlet we have various kind of boundary conditions which we can specify. Whatever the problem we are having, we can change this boundary conditions according to our same like for outlet. Outlet also there are various conditions present. We can select any one of them however we want to proceed. Then one more thing here is this operating parameters. You can change the reference pressure locations and everything over here as well. Next is mesh interfaces. So wherever fluid structure interaction is there, we can use this mesh interfaces. Then a dynamic mesh. Dynamic mesh is where you have a moving mesh. You can use this option. Then it is reference values. In reference values you have to specify from where you are starting your simulation. So these all things you have to put carefully. Then for reference frame, the same as we see in dynamic meshes. Then this name expressions and all are some kind of advanced parameters. So in solution, this is all numerical simulation setup. So what all schemes you want to use for your pressure velocity coupling. Then the spatial discretization you can control over here. Then in controls we have explicit relaxation factors. So we will see how important these relaxation factors are when we are dealing a combustion problem. So we can change these factors according to our need. We can select these equations and we can select that only turbulence equation has to solve first or only flow has to solve first and then we can change. So this way also we can proceed. Next, in report definitions, we can make while solving the simulation, various report files should be generated. So we can give inputs over here. Then same is for monitors, cell registers, and then initialization. In initialization, we can select a hybrid initialization or standard initialization. So in standard initialization, we have an option to select one zone from which we can compute our initialization. So whichever we select, like if we select inlet, then these all things will be initialized from inlet. Then once the solution is initialized, we can select the calculation activities and we can ask ANSYS Fluent to save our data based on our settings. So we can give all these parameters over here. Then it's the run calculation where we have to set up the number of iterations and reporting interval profile updated. And when everything is done, you just have to go into file, then you have to write and then you have to select case. So case file and data file, these are the two important things when you are dealing with an ANSYS Fluent simulation. So whatever settings you have done till now in ANSYS Fluent will be saved in a file that is called a case file. So what all boundary conditions has been allotted to the inlet, outlet, all the zones, the initialization values, reference values, everything will be stored in a file that is case file. So when you are about to start a simulation, before doing the calculate button, you have to go into file, then you have to select this write, then you have to do a case, then you have to specify where the folder you want to save the case file. Then you have to click this calculate button, then simulation will start and you can see all iterations, how they are going over here and the residual plots and whatever monitors if we are given, everything in this display. So once the simulation is done, then writing case again and a data file. So how all the pre-processed settings are stored in a case file, all the solution details after completing the solution can be stored in a data file. So you can similarly write from file, you have to select write, then you have to select data. Since we have not completed a simulation, it is disabled now. You can select the data and then you have to save it where you have saved your case file. Summary for today's class is that ANSYS Fluent is industry-leading fluid simulation software with fast pre-processing and faster solver time. Fluent also provides a platform to solve various kind of problems like electric motor cooling, multi-phase flow, turbulence modeling, and combustion modeling, and so on. So when we model a combustion problem, there are various complexities which we have seen: chemical kinetics, turbulence, heat generation, etc. So Fluent provides outstanding physical models to solve all such kind of problems with good accuracy and less efforts. Also, we saw a detailed demonstration of Introduction to ANSYS Fluent, where we got familiarized with the ANSYS Fluent GUI and the necessary terms involved in modeling combustion with ANSYS Fluent. So references for today's class are present here, and in next class we will start with modeling species transport model in ANSYS Fluent. Thank you.